Yes, today we are in day 3, session 1. Our session is Infusion Artificial Intelligence into all your apps. Today our resource person is from Microsoft. Her name is Miss Deepthi Anantharam. Good morning, Deepthi Anantharam. And
Good morning, everybody.
She has more than 16 years of experience with various institutions. Since 2012, she is working as a solution architect, now senior solution architect at Microsoft, especially in Azure platform. And she has done her BTech from Bangalore University and MTech from IIIT Bangalore in 2003. With this brief introduction, I request Ms. Deepthi Anantharam to take over the session. Over to Deepthi.
Good morning, all, and thank you for giving me and Microsoft an opportunity to speak about the Microsoft AI platform and how we can infuse AI into everything that we are doing today. It goes without saying that it is pervasive. As well, as I was introduced, I have been with Microsoft for 8+ years, played various different roles, and then I have always enjoyed playing with data. Before joining Microsoft, I have been involved in a couple of startups by choice, helping build products. Right. Let's get started to understand what is there on Microsoft AI platform and how it can help any developer or even a non-coder to get started with AI. I had a brief slide to say that artificial intelligence is not new. It's been there from the 1950s onwards when people were trying to segregate whatever came into Hotmail into what is a spam and what is not a spam. We were getting machines to think like human beings. Now, that is a passe. That happens quite easily when an AC can change temperature depending on how many people are there in the room and the weather. In the 80s and the late 90s, we said, well, if a machine can think like human beings and take an action, can it also see? Can it hear us? And there came in machine learning. And so we have democratized machine learning today and introduced a lot of APIs, which we call cognitive APIs, which will help us see, hear, detect anomalies, understand videos, and so on. And lastly, getting deep into it, we have got the deep learning modules, which go 154 layers deep to understand what's happening in a particular environment. Just to say that, why are we thinking of democratizing AI today? That is because whatever the machines can do, it has reached human parity. So in 2018, the machines have been able to read as well as human beings. A little before that, there was human parity in understanding what was being said. It can recognize objects to identify what is dangerous. Are people carrying forbidden objects into a closed space, and so on. So there has been a lot of advancements, and the machines have reached human parity, which is why now we are saying we can safely democratize it without invading people's privacy into all environments. So what is there in the Microsoft AI platform? Which is what we are going to talk about in the next hour before we open it up for questions. We have got pre-built AI, which is cognitive services. In true Microsoft style, when we introduce a service, we want it to be used the most. So we have introduced a host of APIs, which you can call from any programming language of your choice into any environment, and it offers built-in intelligence. Now, when we have pre-built AI, there's another asset to it called the conversational AI, where we can spin up a bot in a few minutes, right? And then we can fine tune it to do much larger things. So gone are the days when a bot would just pop up on a website and say, hey, what can I do for you? Or offer a greeting to make the person more welcome. Today, bots can complete transactions. It can take a car service booking. It can change a hotel booking. It can cancel flight reservations. So that means it is operational 24/7, bar 365, and there are no human biases introduced at various different levels. And lastly, to do very high-end work, we have got custom AI, which also is very, in which also there are a lot of platform things to make it useful. Now, supporting that, we have got CPU, GPU, and FPGA capacity on the hardware layer. And then on the compute layer, we have got Cosmos DB, which is a NoSQL store like Mongo, Cassandra, and so on. We've got SQL Azure Database, SQL Data Warehouse, now also called Synapse Analytics, which helps us to build warehouse both in structured and unstructured data. A data lake, which is a storehouse of all kinds of data. Now, these are mostly the storehouses where you can store any kind of data that you would want. On the compute side, we have got Hadoop, HD Insight, Hortonworks Data Platform, Databricks, and various other things like IoT Edge and Batch AI, which is useful. Now, what would be the point of having all these services and support on storage and compute if it was not for the right amount of tooling? So we have our own cognitive toolkit. You can also continue to use MXNet, Keras, Chainer, TensorFlow, Caffe. In fact, you can build a model on Azure and download it as TensorFlow and run it wherever you would want. These are the deep learning framework. Now, from a coding perspective, we've got Azure Machine Learning Workbench, Azure Machine Learning Studio, and even Visual Studio add-ins to help build the AI platform. Let's get started with cognitive services. So, like I told you, in cognitive services, we have got services which will help us to identify things, which will see things like images, videos, understand what is being there. And then we have got the speech services, which helps us to convert voice to text, text to voice, understand the intent of what is being said. We support about 60 different languages where translation can happen from one language to another. The ask, especially in the Indian scenario, has been on the support of Indian languages. We currently support 9 Indian languages, which caters to 80% of the business scenarios. There's a lot of knowledge on the, there's a lot of data on the web, which can be converted to knowledge. It helps in search. And there are a few things where institutions like you would like to actually play around with the labs and help us in developing new cognitive services. Let's dive a little deeper and understand what we can do with each of them. Here, we are listing out the services that are available in each one. A better way of looking at this is to actually go and explore the cognitive services. Let me now go away from screen sharing and show you the cognitive services that I would want to show. This is the post this presentation. I will share a few links with the moderator and then you could get access to it. Or it's very simple, azure.microsoft.com/cognitive services. And most of the things that I speak today are going to be from this particular page. So let's start with vision. We have got 5 different APIs over here, cognitive services. The first one happens to be the face. So when I open the face, what does face help us to do? A little bit of issue where I would want to look at a different page and it's not allowing me to. Yes, there I go. Okay. So here I am on the face API page. What does the face help us do? It will help us to detect a face, right? We have got inbuilt models. It has been trained on millions of images. So when we upload a face and then we say, what are the features in the face? You can see that when we call the API, the results are returned as a JSON output. So we can find out that whether the person is bald, no, right? What is the color of the hair, which is an important attribute if the person is not bald. In true machine style, it says, well, I see some brown, black, red, blonde, and gray and others. What is the person trying to do? She's a female, aged 25 years, no mustache, no beard, no sideburns, has reading glasses on, eye makeup, lip makeup, and the primary emotion that is being displayed in this photograph is happiness. What do we do with all this information? Well, we have a number of applications today. The first thing is, see, it can even recognize whether 2 people are the same or not. 2 people with, in different backgrounds, in different angles of the face have been put up here. And the person says, I'm 93% confident that these 2 people are the same. So let me just change these from the default picture to some of the other pictures that we have to say what it looks like. I'm uploading one of my photographs, which is quite recent. Okay, I'll upload another one, which has got a different hairstyle, a different angle perhaps, and we'll see what this photograph, you can see that when there's a man and a woman, it says the confidence was 14% similarity. Here the hairstyle is different, the background is different, the angle of the face is different, but still it says 94% these two people are the same. Let me try a very different kind of a photograph and a few, where I used to have like a different, okay, I don't seem to have it in this collection of items. But if I upload another photograph, I'm just waiting for the upload to happen. You can see that, it's a very different setup over here and all of it, and it still says 93.7% these two people are the same. So what does this actually mean? If you are thinking that you need to be picked up by a particular Ola driver or a car employed by a company and the person is not the same, there could be an alert sounded. If the person is not feeling too well and somebody else is filling up for them, which is happening these days quite a bit, especially in this work from home scenarios, even then there is a level of safety and security, especially while picking up kids. Now, if you're in an industry where there could be fatigue looking at faces, like in a passport industry, and the passports are like aged about 8-9 years, and you don't know if the same person is traveling, because in those years the person could have put on weight, lost hair, various other things, got a tattoo somewhere, and so on and so forth. You could use a feature like this because it measures the distance between the eyes, the shape of the nose, the distance between the lips, some things which cannot be easily changed, right? So a lot of applications of using a face detection to see if it's a person, if it's a live person. Now, questions about liveliness detection and all is there, but then it has been taken care of. And here you don't have to actually do anything but to call the API to identify a person. Similarly, we have something called the perceived emotion detection. So if there are multiple people in a photograph, it will tell you what they are actually imagining it to be, whether they are happy, they're sad, and so on. Let me put up some photographs where let's examine this photograph. For each of the face, it says this person is happy. This person is slightly lesser happier than this person. And basically, this is a happy group and everybody is happy. Now, if you're talking to somebody in a different scenario, asking for feedback, let's say in a hospital, and the person has mixed reactions, but their words are actually different, you could use something like this to understand. Now, even KYCs and banks are going the video route, right? So in a case like this, if a person is actually not very confident of what he's saying or is trying to impersonate somebody, an API like this will help us understand where we can go with this. So that was the face recognition API. Now, in the face recognition API, the only thing that we were worried about was the two-dimensional face that came with it. Now, we have got computer vision where it goes many layers deep, understand everything that actually is being, oh God, the screen share tab is acting up a little. Apologies if the screen isn't moving as quickly as what you would want it to be. So what happens in computer vision is it goes various layers deep. It picks up every single object that's there and it identifies the object. Now, the question is, can you train the face API any further? Not at this point in time. Can you train the computer vision? No, we've already trained it with millions of images around the world and built models. All you have to do is call the model. Now, as you can see, there it was only identifying faces. Here, if I put up a photograph, and this one happens to be my favorite, if we say, what do you see in the picture, right? It says, I can see things like people, person, can see a laptop, which is nice. There's some clothing. There's some furniture. Yes, there is some furniture in this thing. And there is also a woman in the picture, right? And then sometimes it gives a caption saying it's a group of people sitting on a table using a laptop. And the confidence that this is what it's able to see is 96%, right? And it also tells us what is the image format, what is the dimension, whether it's black and white, and so on and so forth, right? So we could, this also includes things like OCR. There's a different format to it. It understands all the text that is being said. It can read not only from printed messages, but even from handwritten text and so on and so forth. So the applications are very, very huge, right? Let me play a small YouTube video to tell us where we are making a huge difference to the life of the disabled. I was not sure if I could play the videos, so I don't have it ready. Just give me a second where I stop sharing the video and pull out the video. So here is a video of a person who's working at Microsoft. He's differently able in the thing that, his vision is not as good as what it needs to be. And let's see how something like a cognitive API, a set of cognitive APIs and whatever, and certain device can make a huge difference in his life.
That's where I was introduced to talking with computers, and that really opened up a whole new world of opportunity. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that can tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphone, but also on the Photohead smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces. 40-year-old man with a beard looking surprised. 20-year-old woman looking happy.
Yeah, I can describe the general age and gender of people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. This is Nani.
Okay, thank you. I can use the app on my phone to take a picture of the venue, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate. So I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far off dream and building it one step at a time. I think this is just the beginning.
Well, we've also got an app on the Apple Store, which can help you kind of do these things, experience it on your mobile phone. And we've got a play around app on a Windows system, which I will tweet about again today so that you can download. So the thing is, using some of these things like computer vision, face, form recognizer, video indexer, we've been able to see what Shakib could do and improve his own life and improve the life of others around him. Now, in this, there is something called custom vision. So when we offer things out of the box, we understand that you might want a level of customization. So computer vision is the basis for custom vision, where you can add a few more additional samples to improve the accuracy. For example, if you want to look at a manufacturing line and see if everything that's coming out is manufactured properly or not, in proper alignment, whether it has been packaged well, you could just install a camera over there and call a custom vision service, which will tell you what the anomalies are. To build a model like that, you will have to at least put in 20-30 photos to get the desired accuracy. You can definitely play around with it, for which you will need an Azure subscription. So let's move away from vision and look at what speech has to offer, right? So in speech, well, we've got speech to text and text to speech. I have it open over here in the speech to text thing. So it can speak in any different language. Okay, I need to speak and then it's going to come up in different languages. Good morning, all. I will need to refresh because it's been on for a while. I'm just refreshing the page. Good morning, all. Hope you're liking what you see to explore artificial intelligence around you. This will help us infuse AI into everybody's lives, making it more faster, better, and making India more inclusive. There you can see that, as I speak, it was converting the voice to text and happening in real time. It need not be just Indian English. I can do it into any of the other languages as well. Let me try Hindi. Namaste. Hope you people are all doing well. जब मैं इंग्लिश में बात करती हूं तो वो अपने आप हिंदी में ही लिखता है उसको उसी स्क्रिप्ट में. Imagine a call center scenario. I am not very happy with the banking facilities. I need to change my PIN. What you can understand over here is it can take in English as well. It can understand things like when I'm speaking in English, if I say TK suddenly, which is not what is the norm, but happens often with the mother tongue influence, it does that as well. So as you can see, it converts it into Gujarati, Hindi, Japanese, Marathi, so on and so forth. Let me try saying something in Telugu. Namaskaram. I can't read it too well, not my native tongue. Kannada is my native tongue. Those of you who could read it will understand that it is quite accurate, right? Now, let's look at the other one. I will have to close some of these. How does text convert to speech? And what are the different languages in which it can speak? We are discussing how AI can be democratized. I know there is a typo there. I will leave it in. I will leave the typo in and let us see what happens to it, right? There are different languages. You can decide which language you want that to be read in. Okay, various different languages, including the different ones. Now, if I say that I want it to be read in English, let's start with English because we expect most people to understand that. It's giving you a male voice or a female voice. I just saw a question on whether it supports translation. Yes, it does support translation as well. Okay. And the rest of the questions which does not pop up on my screen, we will look at it, but then do keep your questions coming. So there's a male voice and there's a female voice. So let's say I want it to be read in a male voice and the style could be general. It can speak faster or lower and at a higher pitch or a deeper pitch. I don't know if you were able to hear. Often, when I use a headset with such kind of demos and we are using a normal screen share other than certain things, you may not be able to hear it. But here we are able to offer a male voice, a female voice. Okay. And we are also able to offer voices without mother tongue influence, right? So that was about the speech to text and the text to speech. And then as somebody asked about the speech translation, let's see what actually happens in speech translation. It can easily convert from one language to another. So if I say, Okay, I need to speak and there is a target language. So this is the typical case where we want a call center to support different vernacular languages, and what happens? Hey, I would want to block my credit card. Can you help me with it? Yes. अरे मैं अपने क्रेडिट कार्ड को ब्लॉक करना चाहता हूं, क्या आप इसके साथ मेरे मदद कर सकते हैं? इसके साथ मेरे मदद कर सकते हैं. So happening in real time, right? Now if I say, let's do the other way around. Let's say I want to speak in Hindi and then I want it to be converted into English. नमस्कार, आप सब स्वस्थ है इसकी मैं आशा करती हूं. सोशल डिस्टेंसिंग मेंटेन करें, अपना मास्क जरूर पहने और सीखते रहे. इससे हमारी जिंदगी बेहतर बन सकती है. So it says, hello, I hope you're all healthy. Make social distance. Now you would want the word maintain, but this is where we'll have to do additional things. Wear your mask and keep learning. This can make our lives better. Happening almost in real time and with the support of English, other languages as well. All right. All these APIs, like I said, you just need to go to azure.microsoft.com/services slash cognitive services and then use these translations. We also have a speaker recognition service. Now, like we had Shakib, kind of trying to see where his speech was not impaired, his voice was. Here we have a API in preview, which will help you identify the speaker. So if a person can see but is there is some kind of impairity where you would want to unlock your phone not with just the face but with a voice, or give some commands, and only your car should take your command. Let's say there are 3 people in the car, they're all very noisy and they start saying left and right and so on and so forth. How will the speaker know, how will the machine recognize it is you and your command that it needs to follow? And that we have in the form of speaker recognition. We also have certain other APIs, which comes under the language one. Here, the simplest one to showcase to you would be the text analytics. So what happens in a text analytics is, as okay, I think I kind of understand. Can this window dock a bit so that, yes. So here in speaker recognition, we have uploaded some voices. You'll have to take the user, you'll have to capture their audio, identify the speaker and get the output. And this, when you have given enough voice samples, it can recognize who is making that change and for what joy. We were going to discuss language analytics. I just want it to be visible. 1 second. Here, what happens is it will understand what is being said. Okay, it can identify and categorize important concepts. So let's say you're looking at a Twitter feed or you're looking at a Facebook feed. You're trying to understand what is the feedback that has been given on the punctuality of the aircraft, on the cleanliness of the aircraft, or on anything, right? You have released a new product. It can understand the sentiment behind whether people are commenting on the pricing, availability, shape, features, what is it, right? So you can understand both structured and unstructured data over here and work with it, right? So we have got textual analytics as well. Now we've got another feature. We've got another feature here called the Q&A maker. The Q&A maker actually helps us to create bots. Okay, you have to point it to a PDF or a Word document with questions and answers. It will understand by itself and it will help us to do a bot. Obviously, this will not complete the bot. You'll have to put in some cards. You'll have to have some action items. Let's look at an example of what a bot can actually do in this and help us, which is called the conversational AI. Okay, and then we'll oops. Okay. I'm going to stop sharing for a second again and pick up that set of slides. Just give me 1 second. I'm back onto screen sharing. I'll just give it another minute for the sync up to happen. And okay, here somebody logs into a car insurance site. The bot pops up saying, "How can I help you today?" So the person on the other side, not that you expect people to ask such questions, asks you questions like, "What can you do?" Right? There is an answer in the Q&A maker. So it comes up saying, "I can help you with all your insurance needs." Okay. Whether you're in the market for a new auto or a home policy, or whether you need to make a claim, tell me what you need to do. So again, another generic question, where is your company based? So when you're building a bot these days, right, you can always have things. Can you all see my screen? Can somebody confirm? I'm assuming you can see my screen and hear my voice and see my screen. So there's another generic question.
Sorry to interrupt you, Deepthi.
Yes.
Yes, everybody are able to see your screen and we listen your voice. They are muted. If you want to unmute everybody, I'm going to do that. You want to have interactive session now itself?
No, a little later. I just wanted to make sure, because I stopped sharing and shared again. There was a momentary, it kind of acted up. So I just wanted to make sure people can see and hear me.
Perfectly fine.
Okay, thank you so much. Now it asks things like, where is your company based? Okay, it says, well, we are headquartered in Redmond, and then we have got 52 branches across. Now, things like the person now finally says, I need insurance. Okay. Here, when we type in free text, it's always additional calls to different APIs to understand what is being said. To make life simpler for that, there's a card. There are different things to say. Do you want auto, or do you want home insurance or life insurance? So the person picks up, I want auto insurance. Now, again, having radio buttons, having cards, having clickable fields will always reduce the work that needs to be done by a bot to understand what's happening. So are you an existing customer? The answer is yes. Then if it is a site which is already logged in, you wouldn't need to get the name and other details. But if it is a generic public facing site, then you'll have to ask some details. So it captures the name of the person. She's Alice, and the personal identification number or phone number or customer relationship number, and it does. Now, this is not AI, folks. This is a demo bot, remember? So there is some intelligence built in around to see that whether Allison's family is also listed. Do we have the family relationship over here? So it goes back, it checks that the daughter has turned 16. Can I include her in the insurance? The person says yes, go ahead and insure her as well. So what make of car do you want to insure? The person is just saying Ford, right? He didn't say what it is. So it says, what is the model? Now, this question is not typical. It's not an IVR bot. It is much more evolved. So if the person had said Ford Fusion, this question wouldn't have obviously come up. Which year? The cars are written off in 5 years. So anything older than 2013, probably people will not register. So it says I bought it in 2015. Now, questions like, do you have a photo of the car? Person says, yes, I want to have I have a photo of the car. Can we upload that? Now, this person accidentally goes and uploads the photo of his dog, right? Now, this is where is an excellent example of usage of computer vision, where it says you've not uploaded the photo of a car. Imagine the number of times where we are asked to upload photos of driving licenses, where we are asked to upload photographs of passport. Do we make a mistake? Can somebody check and say that, well, hey, listen, you've not given me the correct one. It says it looks like a dog catching a frisbee in the mouth. Can you upload? Now this person, kind of likes the description, wants to play around a bit. So he goes and he uploads another photograph. Now, we know the Harry Potter series, very famous, John Radcliffe. This is the Hogwarts University. But remember, this is a bot. It will not know that. It says it's a man standing in front of a building, not a car. For me, I cannot recognize that whether it is Salman Khan or whether it is, Sanjay Dutt over there. And finally, it says now upload the photo of a car. The person uploads the photo of the car. And then it says, things like, that looks great, nice purchase. This depends on the personality of the bot. Okay, you can say that you want your bot to be very professional, or you want it to be, have a different personality where it is giving compliments and things like that. Now it collected that it is 2015, Allison and her daughter will drive it, and then it is going to cost this much. If the person had said, go, and the bot is also saying, I'm giving you a 10% discount because you have the existing policy with us, equated to like something like a no claim bonus. Now it says, what do you think? Can I start your coverage? If the person had said yes, it would have just called a web service and had gone and triggered what actually needed to happen. In this case, the person says, no, it's way too expensive. Here, the bot understands that it cannot do any further negotiation with this man, because it really needs somebody with, more human-like qualities. So what happens is, it pulls in an agent into the conversation. This is where we are saying the bots can reduce a lot of L1 support tickets, like in an ITES industry. But if it comes down to L2 and L3, like, it asking things like, is your computer plugged in? Is the power on? Can you paste a photograph of it? Can you share the model? All the basic details are got by the L1 support folks, and then somebody looks at it to understand what's the details. So the bot did all it could. If the person had said, I'm happy with this insurance, let me go ahead, it would have even triggered an email to confirm that the insurance is under process, and it would have triggered the workflow in the back end. Now, when Jane joins the conversation, and she's a human, she has an understanding of what's happened before. So she knows who she's talking to, and she knows what is the quote requirement. This is an example bot. So they start conversing in a different language. Okay. Bonjour and so on and so forth. And then the bot says, listen, the Alice says, listen, this is way too expensive. So the person goes into Dynamics 365, understand what's happening, okay, sees the history, the background, and so on, and gives an additional discount. Okay, when the previous quote was 1,260 or something, now she says 1,200. With this additional discount, this person is actually able to go and close the deal. So, just to tell you that this is the way a bot can work. Where did we come from? We started from the Q&A maker, right? In order to help the Q&A maker, apart from a list of questions and answers, there's also a site called LUIS, which is Language Understanding Intelligence Systems. Here, you can upload JSON files. The site is called luis.ai. You can understand, like if people says hi, hello, good morning, whatever it is an intent, right? If person wants to book something, you can always check whether it is AM or PM, or what time, what slots, and so on. There are some intents that we have available out of the box to help the developers, and there are other intents that you could build. Hence, if you are in a different industry, like an airline industry, or if you are even ordering for a pizza, there are different things that you can create as intents. And now, add flags, add answer, callback. These are all the pre-built domains, or you could create your new pre-built intent to understand what is being said. Once you add certain things over here, you have to just give some inputs of what it is. Save a contact, create contact, add telephone, address. Now, these are all changeable things. Add a new contact. All these would mean the same thing, right? It would mean add contact. When somebody says add contact, it could be like save, add Billy to my contacts, add Johnny to my contacts, add a new contact. I want to add a new contact. Okay. And these are all add dad to contacts, add mom to contacts. These are all utterances that can come in and be told. You will have to type it in. You will have to train it. You'll have to test it. You'll have to publish it. And then the intent becomes available. So there was use of all cognitive APIs, including, analyzing the text and the usage of Lewis to build this conversational AI. Now, let me switch gears. We've seen, you could explore the rest of it. There are things to say. What is an anomaly detector? What is normally there? Content moderator to say whether there is any adult content, there is any racism content. So if you have a public facing website, you could normally use a content moderator to do the first level to say that whether this is age appropriate for somebody to use something like this. And lastly, I would never want to go without showing the search to say that I'm just going on to Bing search, right? Now in Bing search, I'll say I just want to look up for lions, okay? Until then, just look at what all is there over here. I'll say I want to look at images of lions. Now, when I say I want to look at images of lions, there are certain filters that automatically come up over here. What are these filters? This comes from a big learning background. Who would think that a lion has a color, right? A lion is the color of a lion. That is how you would describe in a lot of languages, actually, kesari or saffron, right? Now, if I say I want to look at yellow lions, do they really exist? Well, some hue and color. If I say I want red lions, do they exist? Now, you can see that some of these are, it could be to do with a logo, it could be to do with other things, but you got it. So how do we add these colors, right? Or even the type of picture. Do people look for only clip art that they can include cute things into others? Are people looking at only line drawing that they can, print out and maybe color and so on and so forth? There are all these things which get added to say, do you want wide, square, tall layout? If you're looking for people, do you want just faces or you want with head and shoulder? Image size, at least what pixel in height, what pixel in width, and the date when it has been published. If you're constantly dealing with images, if you're searching for images and you don't want to come back with the same image again and again, you could say, just show me something that has been uploaded in the last 24 hours and only those images will pop up. And something which I find very useful because I am not very artistic. So if I need to use an image, I want to make sure it's free to modify, share, and use commercially. So when a picture gets uploaded on the internet, let's say you have a website and it is not private website, it's not your content, a lot of tags like what is the image size, what is the color, whether it's a line drawing, clip art, photograph, what's the layout, when has it been uploaded, all these metadata tags get added to those images if you make them public, and then it helps in being discoverable, right? So you can use the search to search for content even within an organization. You can okay, so there are a lot of Bing search APIs over here, which will help you search for content, images, everything in one go. So here was an overview of what we could do with pre-built APIs, okay, and with conversational AI. Let me now switch gears and show you how we can go about building a custom model and how simple it is. I will promise that if you follow all that I do in the next 15 minutes, you will be able to build a simple model by just having an Azure subscription, which also you can sign up for a free trial. Okay. Now, I have created an Azure Machine Learning Studio. This is the Azure portal, portal.azure.com. If you don't have a subscription, please go and sign up for a free subscription. If it asks for a credit card, do not hesitate to bring that on. So what do we intend to do with this? A few starter slides, which will help us. So let's say there was a time when people sent out a lot of postcards. Diwali season, Deepavali season, the best time to do it. Christmas, New Year, people do send cards and postcards and so on. People wanted to sort out automatically by this letter. So identifying this as 220, it probably somebody with basic skills could do it. The problem is different handwritings. It would be written in, in different places. You could write it at the center, you could write it at the left, right, bottom. The positioning was not fixed. So how did you understand? How did you understand that this was really 2? Here, the sample is finite, 0 to 9, show different ways in which it can be written. For example, you can see 5 in the first line. Okay. You can see the 5 in the second line, which is more tilted. Okay. You can see 2 5s in the third line, one which almost looks like an S, the other one which is broken. You can see a 5 in the fourth line where it is almost touching, the 5 is not very clear. Now, once it has been given some samples, it will understand, and then it will go and do the needful. The complexity actually comes in when you have to do the same thing with the images. When we are doing with numbers, when we are doing it with characters, it is smaller in size. When you have to do it with images and it has to recognize me as a human being, I could have different hairstyles, I could wear different clothes, I could put on weight, I could lose weight, I could chop my hair, I could grow my hair long, I could carry different accessories. Like, do you see all these women carrying different purses, different handbags? I could be carrying a laptop bag. I could, how does it still recognize me? That is where the scientists have said you have to identify certain key body portions and certain dots and identify. This is how a lot of Xbox games are being played. Now, the thing is, when you had to actually come up with image samples like this to understand digits, it was easy to get the training sample. Now, for images like this, it is almost, the use cases are infinite. So how can you do it? I mean, I could go tomorrow and pose with my family, tomorrow only with my mother, and so on, right? So how does this happen? Here, getting training data is very expensive. So training data is also kind of synthesized to make it cheaper. Then it understands the body portions, and then it understands things like you are throwing something. So you're playing virtual cricket, or you're doing a bowling action, and so on. You're waving to somebody, and that is how things happen. So basically, machines are very good at doing 4 things. Okay, 5 things rather. One is classify. Classify, this is good, this is not good. This has passed QC, this is not passed QC. So things like, this is a restaurant. By looking at the menu, can you say whether it's a Chinese, French, Indian, Italian, Japanese restaurant? Possible to do it. So it could be a binary classification like good, bad, true, false. This person is diabetic, this person is not diabetic. This person needs a cataract surgery, this person does not need a cataract surgery. 2, classification. These people are under 10% risk, these people are under 50% risk. Regression. So in classification, basically, you are not doing much, right? In classification, you are just bifurcating. In regression, you are coming out with a value that can be used for prediction. For example, what will be the stock value tomorrow? What will be the currency value? What will be the temperature tomorrow? So you're coming up with a new number. That's called regression. The third thing is ranking. You search for something. How does it? Can you give me the best player to open in an IPL tomorrow? Can you folks hear me? Somebody said just do the audio checking once again. I don't see any disturbance either in my network connection or moving away from the mic or anything. Okay, thank you so much for confirming that I am audible. The third thing is ranking, right? So if you say, can you recommend the best player? Can you recommend a good image for me? Can you recommend a song? If you're looking at YouTube, how do you get the similar kind of videos, right? Because you like that content. So there's criteria by which certain things can be ranked, and that would be ranking. The fourth one is clustering. If somebody has posted a tweet, is it related to this event? Is it just related to AI and machine learning? Is it related to Microsoft? How do you do that? The clustering is also very important when you're trying to open a new store or a new branch. What kind of demographics are there in that population? What kind of SKUs or items should you stock? And what should be the return of profit that you expect? The behavior is very different, right? For example, if you start something in a border area between two cities, whether, what kind of audiences should you cater to is what is happening in clustering. Today, we have a problem of plenty. We have a lot of data. If I say, in a student database, what should you have? You will say, well, name and date of birth, probably some amount of marks, and so on. Nobody will say, I want to maintain the height, the weight, the body measurements or vision correctness, and so on and so forth, or health parameters. Why not? You don't know what kind of an industry I'm referring to. If it was a modeling agent industry, or if it was even for pilots, or if it was for air hostess where certain measurements are essential, you would have to do that as well. Today, we have a problem of plenty. For a particular product, you could have like 80, 100, 200 attributes. Which of these attributes are more important than the others is what is dimensional reduction. These are the problems that can be easily solved with custom machine learning. So let's actually see how we can do that. And this would be amongst the last things that I actually will show you as a demo, and then we'll take up the questions. So custom machine learning. I have gone ahead and created a service. Now, this is the Azure portal. To create any service, you'll have to just go and say, I want machine learning studio workspace. Okay. Pay attention over here because there's a machine learning studio classic workspace, which is what I'm going to show you about. This is the one, machine learning studio classic workspace. I have clicked on the create button. I have filled up the form to say which region I want a deployment to be in. Azure is available in 54, 57 odd regions around the world. Most services are available in most regions. So you can pick up the one that is more closest to your customers or developers, depending on what scenario you're handling. And then I have clicked on it and it becomes available. It takes about 3-4 minutes for the service to become available. And now, as you can see, I am going to go to that resource of Machine Learning Studio for the first time. Okay. Now, what I would want to do with this is to actually build and I want to go to Machine Learning Classic. And here it will ask me for sign in again. It will use the same credentials because I'm in the browser of what I had used to sign in into my Azure portal. This is a drag and drop interface where we can build custom models. I'm going to create a new blank experiment. Now, there are 3 things. First is you can search what you want over here. We'll see what are all options available over here. You have a place where you can create your experiment and you have a place where you can set the properties. So we will do US census salary prediction. Okay. This is actually real data that we will use of the data in 1980 to say whether the salary is less than 50K or greater than 50K. So there are some saved data sets. There are some samples. I'm going to use this adult census income. Okay. We want to do a binary classification of this. The moment I drag and drop this, it will say what is the size of the database. I can even go and visualize this data. So you don't have to write any statistical code. You can see there are 32,000 rows, 15 columns. If I click on age, it says the minimum age at which we have recorded somebody earning is 17 years. The max is 90 years, right? There are 73 unique values, 0 missing. It's a numeric feature. It also gives you a histogram to say that, well, there are not many people who survive to this age or even add. If you click on a non-numeric field, a verbal descriptive field, it says most people are privately employed. It's even giving you a percentage and number. Some of them are self-employed, some in the local government, self-government, state government, and so on and so forth. It also says there are some missing values, at roughly 2,000 missing out of 32,000. You can look at the weight of it, and it's a string feature. Let's not look at this for every individual feature right now. Basically, there's age, there's work class, there's education, marital status, occupation, race, gender, and so on and so forth. And what is the income? Now, we want to see if we pass a sample, how do we get this? Well, first is we will do a select columns. When it is running the experiment, I will show you what is available. The select columns will tell us what columns are important for this experiment. There is no right and wrong. It's an experiment based on the industry knowledge that we have. We can say that there is age, there is work class that's important, there is education that's important, there is marital status. People who are happily married are supposed to be working, earning more. The occupation is important. The race, unfortunately, how much an average Indian earns versus an average American versus an average Chinese versus an average Australian is different. Gender, we know that men are more heavily paid in the industry. The number of hours a person works. Since we are predicting the income, we will take the income as well. Okay. In fact, I will take out the race and add the native country over here. Okay. So there are basically 9 columns that we have selected. Now, in any machine learning experiment, as you would all agree with me, we'll have to split the data into 2 portions. A portion which we'll use for training and a portion which we'll use for testing. I can split this data by using a recommended splitter to say include all people who are working in private organizations, include all people who are female and so on. But for now, I will just do a randomized split. I will take about 75% of data for testing, for training, 25 for testing. So did a random split. Now comes all the algorithms that are available for us, right? So there are a bunch of algorithms which are available. If you need, for example, if you want to detect anomaly, we have got one class support vector machine and a PC anomaly detector. You can also use various classification algorithms, which is what we need to do over here, either a two-class classification or a multi-class classification. Okay, and we've got clustering and certain regression algorithms as well. Okay, so what do we do over here? I can use any two-class algorithms over here. The moment I say I want to use a decision forest, the parameters that I can pass to decision forest, like whether I want to use bagging or replicate method, whether I want to use single parameter or parameter range, pops up over here. And this would be different from when I want to say I want to use logistic regression. Okay, so here you didn't, the optimization tolerance was not there in decision forest. So we'll go with the two-class logic regression. Then we need to train the model. We need to score the model, and we need to evaluate the model. This is what we will need to do. Okay, so we will say we want to train the model using a two-class, sorry, let me just minimize this a bit, move this so you can see everything. We will say we want to, the split of the data, we want to train the model using a two-class logical regression. We want to train it on this particular column called income, right? You can train it on multiple columns as well, but we want to train it on income. When the model is trained, we want to score the model to see how much of it we got correctly. We want to verify that by using the second data set, which we have preserved, and then finally evaluate the model. I'm going to execute it. Well, when this is executing, I will speak of a few common questions that get asked. What if you're not happy with all the algorithms that are available? You can integrate this with notebooks. Okay, so you can bring in your R code, your Python code, and do it. How much of data does this support, right? Why is this question asked? Because we didn't define storage. We didn't define what compute machines we want to use, CPU, GPU, 100 cores, 200 GB of RAM, and so on. We didn't do that. Because this is a service available out of the box, you don't have to worry about any of those. Okay, so the amount of data that you can train this is pretty large. You can go ahead and do this. And while we are talking about this, let me show you. There is R language. So you can create an R script or you can execute an R script from here. Okay, and then we also have a Python language. You can execute Python scripts. So it's going to be pretty good. Now let's actually go and see how we have done on our experiment. We have got 8,000 rows, which is 25% of 32,000, which was the original rows. And you can take a look at the samples. Basically, this is the income that was there. Okay, this is the scored label. Now the scored means somebody 62 years working in local government who's a high school grad with a married civic spouse, working in the transportation, male, who works 40 hours. The actual income is also less than 50K. The machine also says it's actually less than 50K. Okay, and the probability that this is the probability of that being less than 50K is 33%. So you can see that in most cases it is going to match. In some cases it may not match. Okay. So how much of it matches, how much of it doesn't match? This is where we'll have to use the evaluation of the model. This is called the area under the curve. The more closer this is to 1, the better it is for accuracy. Okay. So we also have got this threshold to say that anything which is true and true is good. Like we have got a precision of, we've got an accuracy of 83%, which is pretty good. We could improve it further, but for now, we will not improve on that. We'll say that anything with the 80 to 90% score is pretty good. Even 75 onwards is pretty good. You can move the threshold and say that, if you're giving away something like McDonald's vouchers and see if people will encash it, you can go with a 30-40% accuracy. Even if there's a 30% chance somebody will do it, let's take it. If you're trying to do cancer prediction for a large for a group of people, you want to be more accurate, like 80-90% accurate. And as you change the threshold, what should happen when somebody is at 50%? You can see that the numbers, the confusion matrix also changes. Now, the most important part of this, how do we deploy this? We've built a model. Let's assume we are happy with the model. We are pretty happy with the model because we've got more than 80% accuracy. How do we do it? So I'm going to save this as a trained model. I will call this the income predictor. Okay. And I'm going to make some changes over here. I don't need the algorithm anymore. I don't need to train any more models. I don't need to evaluate. I know it's going to give me about 82% results. I will put back income over here. This is my trained model. I'm going to take it and score it. I don't want to split the data anymore. I want to directly do it for every row of data that I come across. When now I don't expect any income from my I don't expect any income to be given. I want to be able to predict the income. So I've done a bunch of changes. It is like just moving out things that I have already used, discarded them, and built the model. Now, there's one last step that I will have to do before setting up this as a web service, which is I'm doing a control C and a control V like any normal developer would, and say I want to select the columns in the data set. Why? Because this data set has got so many different columns. Actually, I don't want any of these, right? My answer or my interest is in the scored label and the scored probability. The rest are all questions that I have for myself. So what I'm going to do at this point in time is going to run this model one final time. When I have finished running the model, there are certain web parameters that we can set up. So there's an input that I'm going to give, and there is an output that I want. Okay. And so I'm setting up web parameters where I can pass questions and get the output and do a final deployment. Okay. Now I have just clicked on a button to say that I would want to deploy this. And when I deploy this, I will get a web page, an HTML page. So if I say I want to test this, okay, first of all, if you wouldn't want to deploy it, you can just take this API key and call it from any place that you want. The model is going to be hosted on Azure. This is the API key that you can call from any application, including an on-prem application. If you want to do a batch execution, you can pass all the inputs, like, you're doing a KYC, you're giving a loan, you want the risk percentage. You pass it for about 50 applications that you have received that day, and you will get a score. But here, I would want to showcase what can happen. So let's assume I'm a bank employee. I'm sitting in a bank. A person comes to me. I want to see what is the risk factor if I grant him loan. Somebody 39 years, works in state government, bachelor's, never married, admin clerk, male, 40 years, works 40 hours, native country, United States. He gets less than 50K a month. Let's say somebody is 49 years old. He works in federal government. Okay. And then he has got a master's, and then he is married with civic spouse. Okay. He works as exec management. He works in a management position. Male, 40 hours, United States. If I do a request response, you will see that he also earns less than 50K. If I say he works in private government and he has got a master's and he's a director of a company and he works 45 hours per week. Okay, you can see that the percentages are changing. Now, to automate this any further, you can use Swagger APIs and you will get what should be the input, what should be the output. So I'd want to actually, summarize a few things for you. Whatever we have deployed here as a model, you can also go ahead and Dockerize it and even do an edge deployment. We have another service called Azure Machine Learning Service for that. What we use is Azure Machine Learning Studio. We have got a website called gallery.azure.ai where you can look at a lot of these deployed models. Okay, so deploying onto Azure IoT Edge, containerizing it, all this is possible. In fact, cognitive services is also available as containers. Okay, and lastly, I have got a few set of questions for you to answer, which we will bring up. I would want to showcase some of the models that have been running very successfully. Churn analysis. Will this customer leave me and go? Because the cost of acquiring a customer is far heavier than managing one. Social network analysis. I mean, everybody writes a complaint if they're not happy. They put it on Facebook, Twitter. You can't ignore those. Recommendation engines. What should I best do? Location-based tracking and services. Even IT infrastructure, whether it is being optimally used, not used, weather forecasting, legal discovery and document archiving. Now, there are two industries where documentation and digitization is pretty tough. One is land records, which certain governments have done a commendable job about, given that there are various different languages, images, and so on. The other is medical fraternity, where people don't understand what is being said. Okay. And then there is legal discovery and document archiving. There's also equipment monitoring, advertisement analysis, whether you had a billboard or whether you flashed something on a small way, did it really help? Pricing analysis, most human beings don't decide on the price of product these days. They just have a range and the pricing is dependent on the inventory, number of people doing the search, just like how the air tickets can go up and down. Fraud detection, did you make a particular transaction or no? And personalized insurance. Well, now I'm going to stop sharing my screen and actually take a look at some of the questions that you people have been asking. And post that, we look at a few questions that I have to ask of you. Okay, there are a lot of SNOs and a few good mornings. Good morning, all. A warm welcome once again to day 3. Okay. Kumar Vikas, is he completely visibly blind? I'm assuming this is about the video of Shakib Sheikh. Yes. So at the age of 9, he was legally blind. Okay. But he has seen the world. He's been able to understand what it looks like, and everything is not his imagination. And given the fact that he was able to see at one point in time, and he's, the cognitive abilities are good, he's able to use tools and technologies to do it. Translation, Kanwar, I want to speak about, a service. Let me just share back my screen for that for a second. We didn't speak about any of the customizations that was possible. Okay, so let me actually speak about speech.microsoft.com. Okay, here you can get started with the speech services. What happens is you can upload. I told you we have custom vision, we have custom speech. You can build language models and you can build acoustic models. So when you say I want to create a new one, it will ask you from which Azure subscription. Okay. And which region. Okay. I want to create. It will ask you to upload certain samples. Okay. When you upload the samples, you have to upload voice samples. You can do custom speech. That means if there are 3-letter acronyms that is being used in the airline industry, like the seeds are called, Alpha and Delta and so on. Or if you want to see what the medical fraternity is using, you can do the languages. You can also look at if there is a constant noise in the background. If it's a manufacturing industry and if there is constant shuttle going from one place to another, or if it's a call center industry and there is constant noise in the background, you can build a acoustic model to ignore that. So it will actually understand when something is put on hold, how is it put on hold? Okay. Let me play a very small brief demo, given that we have got a couple of more minutes, a video of a place where we are able to do this in a much better way. 1 second, folks. Okay, this is call center analytics, a good understanding of how PII information, that is, which is personally identifiable information, is not when it is converted from voice to text, it is not stored. It can be used only for that particular purpose. Okay, in real time, it helps a call center agent understand how the person on the other side is doing, and gives them what is the most important word that is being used. Okay, so basically this is a logistics or a delivery company. There has been some delivery which has not worked. We will not play the entire 3-minute video, and there are certain things that the agent has to do, like, greet the customer, mention the name of the company, apologize for any inconvenience. We can see that in real time. We can also understand whether these things are being done by the agent, and what is the most important set of words that the customer is using. Let me play this video for a minute so we'll understand this better. So, couple of things. The moment she says, Namaskar, मैं आपकी किस तरह सहायता कर सकती हूँ, there was always, there are two things which that agent has done. The lady who's speaking. Now, 24 तारीख को मैंने delivery schedule किया था. Delivery is an English word, so it understands English. It is also able to distinguish what one person is speaking versus what the other person is speaking.
हाँ 24 तारीख को एक्चुअली फोन आया था 24 तारीख को
So you will see what happens towards the end. The moment she says, maafi chahti hu, the apologize also got ticked. So you have a real-time dashboard, not only to give information on what has happened, but also to understand what the agent should do next, and what is the most important piece in the conversation. There's a Tariq, and there is a Chobis, and there is a lot of PI information which is more about the mobile number. So you can understand that, with this, there is a lot that can be done in the form of both transcription and transliteration. Okay, can we get this API? Like I said, just look for Azure Cognitive Services in the choice of your browser, and then you can look at various different APIs that are there. There are a couple of times where people have said not audible. I have checked it, and I think I was audible most of the times. So apologies. But if there's anything that's not been very clear, we can always have a chat. XG Boost. So Dr. Kriti Mathur, yes, we can use XG Boost as well. In fact, let me go back to my screen and look up for if we can do an XG Boost. 1 second. Oh God. Okay, this was the web service. If I go back to the experiment and look at this experiment, which we kind of did in a hurry, okay, here are the classification algorithms. Okay, and then we had some regression algorithms and clustering algorithms. So for the rest, if it is not there, you should use a Python or a script. But we have got a lot of cognitive APIs. For example, if you want to do detect languages, or if you want to do like entity recognition or a Whopple score, it is possible to do it as well. Okay, I doubt if XGBoost is available directly out of the box, but then there are ways in which you can do it. The other things about the studio is this is if you're doing a small experiment with a limited set of data, you can do manipulation, like you can clean missing data. What do we mean by that? You can say that, you know, what should be the minimum value, what should be the maximum value. If it is to clean it, can you replace the data with a median, mean, mode, replace the entire row, remove the entire column? What can you do? You can get data from two different sources and join it also based on a set. Okay, and then you can group data into bins, which is all normal features available out of the box. You can say how many bins you want, and you know, whether it is numeric, and what should you do. Should you do an in place or a result only kind of a thing? So there are a number of different things available out of the box over here. You can even do things like train clustering models, sweep clustering and all. We also support hyperparameter tuning and AutoML, but that's in a different service called Azure Machine Learning Service. Okay, you can also do some time series data, like time series anomaly detection. So especially credit card information and so on and so forth, you could do that. Let me go back to look at the questions. Okay. Is it possible to convert MP4 into PDF video text using these resources? Sir Prakash Subramanian, I don't know why would you have a requirement to convert MP4 into PDF video, but that is not possible at this point in time. You can just use the MP4 and speech services. If you have a video, you can use that in our video services. Okay, we have a video indexer. The video indexer will say where all a particular a person has appeared and what is it that they do. What type of DB is used in ML? You can store the data in any of the databases. We would prefer that you put it in Azure storage, okay, a blob store or a machine or a data lake store. A data lake store preferable. Okay, looks like the popular question is how do we get an MP4 video to get converted into PDF, right? No idea. All right, folks. If you have any other questions, you can continue to chat or speak as appropriate. I'll be happy to answer questions. In case we are not able to, complete the conversation here, we'll be happy to schedule some time and discuss particular issues. I may not know all the answers, but we can bring in people from the product group who can help us answer. I hope this session was useful, where we've discussed and seen how easy in some ways it is to use Azure Machine Learning for cognitive services, for conversational AI, and to make all apps intelligent. Okay. Balasubramaniam and Vishwanathan, Azure for Education, absolutely. Please work with Prajot. We are happy to come and talk to students. You don't have to be worried about the subscription. There are various different things that we can do. At the bare minimum, please sign up for an Azure subscription. You get $150 worth of free credit, valid for 30 days, in which you can do a number of things. And there are various different things available for education as well. Any other thoughts, comments, feedback you have? Happy to share, discuss it with you folks. Otherwise, we have another 2-3 minutes left. We'll have to invite the next speaker, I guess. I am on. Thank you so much for everybody who enjoyed this session. We are living in a very different world where this could have been in person. But then I am glad that we have made this useful. Do continue to explore cognitive services, build bots, look at Lewis, look at customizations that is possible, and of course explore Azure Machine Learning Service.
Yes, Deepthi.
Yes, sir.
Yes, it is wonderful lecture, and really I enjoyed my personally, and very nice session. And our people like how the way cloud will come into the picture here.
All these services are cloud based. For example, Azure Machine Learning Service that we use is hosted on Azure. That is the only way you can get to use it. Cognitive services are all hosted on Azure, but if you want to do on-prem, then you can use it within containers and deploy it wherever essential. Again, conversational AI platform, things like Lewis, understanding the intent, is all services available on Azure, which makes it simpler to use.
Okay. Now the second thing is is there any questions? I have given unmute option to everyone. You can unmute, you can ask some questions. We have 3 more
Sure.
minutes. Yes, thanks a lot.
Sure. I had a few questions. I thought, I could ask you to name some cognitive services. As you can see, there are about 34 different services. So, feel free to experiment with them. A lot of these services, you don't even have to have an Azure subscription. You can go upload your own photographs, upload your own images, and see what happens. The second question I have is, what makes the Azure ML Studio or the designer so powerful? One, because it has inbuilt algorithms. Second, because it has got an easy drag and drop interface to create models. And third, you can complete the life cycle by deploying. Remember that operationalizing machine learning studio is always models is always a different scenario, but here developers or business folks who are doing the models can do it end to end. And the last question, Indian languages. This is something that we are promoting in a big way because we believe that, India deserves this. So just be aware that we have got various different languages which are supported. It caters to 80% of business communication that happens, and you can build custom models. So anything from call center scenarios to, just reading out of a textbook or a storytelling book could massively benefit this. Any other questions that you have, happy to take it.
Yes, I will forward. You can write a mail in case if you have any questions. And I believe we can leave Deepthi now. And thanks a lot, Deepthi. Once again, we are going to meet her again around. I think your session is tomorrow also, right, Deepthi?
Tomorrow we are here to talk about big data.
Yes, you are very lucky that you are having first session. Everybody will be fresh, and you can inject all your ideas and knowledge to all of you.
I hope you enjoyed it as well. Thank you so much for having me here. Thank you.
Thanks a lot, Deepthi. Thanks a lot, Deepthi. Yes, yes, you can wind up now.
Sure. Thank you so much.
Yes, I request all the participants to fill up your attendance now. And now you can leave. You be back exactly at 11:45. And we have one more, like all the people who were, I have made it arrangement. All are top experts from Microsoft. And we do have very good connectivity from Microsoft Azure because all of our services was hosted in our Azure platform. And go back, go and take small rest and come back at 11:45. Thanks a lot.